All right, so what we're going to do in reviewing for the final exam is go over examples. And that's all we're doing. Hopefully learning nothing new, hopefully, but we will see. So what we're going to do is I'm going to put up an example on the board. You're going to work through it, and we're going to see what answers come up. And then we're going to compare those answers. And that way we can see and talk through where, if any mistakes are made, where those mistakes took place. Okay? So, first one ought to be relatively easy, but we'll see. All right. So one way of saying to do this question is to simplify. What method would you use to simplify this?
FOIL.
FOIL, very good. So let's see what y'all come up with. All right, so what are some answers that we are getting? Somebody call one of your answers out.
2x squared minus 3x minus 20.
Okay, anybody have anything different? Anybody? Are you sure? Please have something different? No?
Well, I had the first time, I did it 2 ways because I couldn't remember which way it was. The first time I came up with 3x minus 8x plus 5x minus 20, but if you simplify it, it's something like we did that.
Okay, so did you end up with this? Or are you still working?
I have to simplify it because it's all the x's to do so.
Well, we'll start off by saying that if you didn't come up with this, then you're incorrect. Because this is correct. So, let's do the FOIL method first. The first, so 2x times x is 2x squared. Because x times x is x squared. Okay, then the outers, 2x times a negative 4 is a minus 8x. Then we have the inner. 5 times x is a positive 5x. And then finally, the last, positive 5 times negative 4 is a negative 20. So this is what we have. Now these two are like terms, so we have to simplify them. So that gives us 2x squared, negative 8x, plus 5x is a minus 3x, and then minus 20, which is what we have right here. So there we have it. Any questions? Nope. Alrighty. Let's do this one. How about c squared minus c minus 72. Factor that. Everybody already done? All right, so what do we have?
Is it c minus 36 in parentheses squared?
C minus 36 squared? Is that your answer? Okay.
Oh, wait, actually, no,
You want to stick with that? Or you want to get rid of it?
that's wrong.
Huh?
That's wrong.
Okay. Any other answers?
C minus 9 times C plus 8.
C minus 9 times C plus 8. Okay, anything else? Anybody have anything different?
I don't know what I did, but I had 2c squared minus 72. And I factored it all the way.
Okay.
I said C squared, or C minus 72.
Okay. So what we're doing is, just to kind of review, this negative 72, we're trying to find factors of negative 72. What times what equals negative 72 when added together will give us a negative 1. Make sense? Everybody remember that now? Oh yeah, that's so right. So 36 and 2, negative 36 and 2, or positive 36 and negative 2. What else do we have? 12 and 6. We have negative 12 and positive 6. Positive 12 and negative 6. So far, do any of those added up when you add them together equal a negative 1? No, this would be a negative 34. This would be a positive 34. This would be negative 6. This would be positive 6. Well, 8 times 9 equals 72. So negative 8 and positive 9, or positive 8 and negative 9. Which one of those is going to, when added together, equals negative 1?
Negative 8 and 9.
What's that?
The negative 8 and 9. Wait, no.
Gives us a negative 1.
8 and negative 9.
8 and negative 9, right. So we plug those in, C minus 9 and C plus 8, and that will be our answer. C minus 9 times C plus 8. It doesn't matter which order these are in because we're multiplying. And so from here we can check our answer. Negative 9, C times C is C squared. Negative 9 times a positive 8 equals a negative 72. And then negative 9C and positive 8C would end up getting us back to here. Cool, makes sense? Awesome. All right, let's try this one. Negative 2x minus 7 is greater than 13. Solve for x. We have some answers? All right. Let's call them out. Who has an answer? X equals what?
-10.
That's what I got.
No. Not
Wait, hold on.
plus.
Very good. So far,
Oh,
not
greater.
equals.
No.
So hold on. We'll do this one at a time. You don't tell people no. Who you think you are?
You're wrong.
So x is greater than -1,
-10.
-10. What else? Is that what you got?
X is less than
Yeah,
-10.
that's what I got too.
X
Okay.
is less than -10. Well, that's weird. What did you get?
That's what I got.
Okay.
You have to switch it.
Oh, that's right. All right, so let's see what happened. Here we're adding 7 to both sides. So -2x is greater than 20.
It's like, yeah.
Now we're going to divide by -2 on both sides, but what happens to this when we divide by a negative?
You switch it.
We switch the sign. So that gives us x is less than -10. Very good. That is always really good to remember.
Is
Because-
it only whenever it's a negative or if it's a positive too?
No, only when it's a negative. Only when it's a negative. Otherwise, positive keeps everything the same. I can pretty well guarantee that on your ACT or SAT, you will probably see something like that on there. That is a rule that should be remembered, and I guarantee you they're going to use that. So, that's a good one. Okay, let's do this one. Let's see if y'all remember this. Since y'all did an awesome job all week long, I know y'all are studying and taking notes and getting ready for this test next week. So let's see how this one works out. So the absolute value of x plus 4 minus 16 equals 8. So before we start off, what does absolute value represent?
Distance from 0.
Distance from 0. Very good. Okay, so with that in mind, it ought to trigger something that will affect your answer. Z. All right. What are some answers that we have?
X equals 20.
X equals 20.
That's what I got. And negative 28.
I got
What's that?
And 2 answers, right? This
We'll
problem?
see.
Okay, I got x equals 20 and 28.
X
Negative 28.
equals positive 20 and x equals negative 28.
Yeah.
Anybody get any different answers whatsoever? So negative 20, or you got 20, 20, some good vision. Go good? Still got somebody working? Okay, so first of all, what we want to do, this, since it is, we'll go back and kind of review this issue. What value of x will equal 5, let's say? The absolute value of x will equal 5. 5 being distance from 0. So what numbers are 5 units away from 0? 5 and negative 5. So that's where we have two answers. Okay? Now what we do with this is we will set up basically two equations. We'll take away the absolute value. We have x equals 5, which is the original one. And then x equals the negative of whatever that is. Okay, so we have x equals 5, x equals negative 5. We use the same method for this equation up here. We'll first move the 16 over to where we have the absolute value of x plus 4 equals, I'm sorry, that's 24. Yeah, 24. So we're going to have two equations. X plus 4 equals 24. And x plus 4 equals negative 24. So now we subtract 4 from both sides. X equals 20. And then on this one, we subtract 4. So x equals negative 28. Does that make sense? Mm-hmm. So whenever you see this, know you're going to have two equations. Two equations. Absolute value always gives you two numbers. Except unless it's 0, because then there's no units away from 0. Do you have a question?
I worked it out differently. Does that matter? I just, I kept it in that equation, but I took away the absolute value signs for one equation, and then the other equation, I took away the absolute value equations, and I just put negative x minus 4 minus 16 equals 8, and then I just kind of...
Well, and what did you ended up doing the same thing.
Yeah.
Because it's just, you put, instead of putting the negative on this side, you put the negative on this side.
Yeah.
Okay, so in the long run, you're actually taking an extra step by doing that, but you're still going about it the same way.
Okay.
So that's fine. As long as you're understanding what's taking place, that's what's necessary. Okay, everybody got this? Meanwhile, all of you are diligently writing notes, thinking, I hope these are the actual questions on the test, because he keeps looking over at that piece of paper. These are not.
How do we know you're not taking notes? How do we know that you're not
You
taking
don't.
that?
You don't. In fact, that's a really good question. My poker face. What do you think is really taking place?
I think you're thinking of why total yes.
Yes. Which means I keep looking, because you got to factor this. All right? Why would I now ask this question that I just did? Knowing that you are watching me look over at a piece of paper. So now you have to consider, since he's aware of us looking at him and him looking over at this piece of paper, is he even looking at a piece of paper that has anything to do with Algebra 2, and he's making this stuff up? And is any of this stuff going up on the board even on the test? Or is this stuff that he wants to cover because they weren't on the test, and so we've got to prepare other things because this is easier stuff? What do you do with all this information? I don't know.
We walk up and look at the paper.
Well, you can. You could do that. Yeah, look at that.
Thanks for
Good.
volunteering.
You got that? All right. Yeah. So, which is interesting. So, I still highly suggest that y'all do some other studying apart from what we're going over today. Or what may happen is what we're learning right now are pieces of bigger problems for your test. That's a possibility.
See, that's what I was going to do.
Yeah.
Benefit of the doubt.
Yes, benefit of the doubt.
Or he's worried we're gonna look at it.
I know.
He's worried.
Oh, I'm not worried. In fact, it'd be funny. See the disappointment on your face when you're like, oh, come on. Hey, you'd be so frustrated, it would throw you into a mental loop. You'd just probably get up and just walk outside the class. I'm so done. Just so done. All right, let's do this. We're going to do a function of x. Hold on, let me see what this piece of paper says. Uh-huh. Yup. Okay. So we'll do x squared plus 2x plus 1 when x equals -2, 0, and +2. That's the information you're given. Let me know what you come up with whenever we're done. Touché. Well, good. All right. Let's hear some answers.
One, 1, and 5.
+1, +1, and 5.
I have 1, 1, and 9.
Wait,
X equals 1,
Yeah,
1,
9.
and 9.
it's mine.
I got. Wait, are you talking about like if it's like is that the answers for x, right?
Yeah.
So I got -7, 1,
-7, 1, and 9. Okay. So let's see what happened. -7,
I changed
1,
mine.
and 9. Nope, can't do that.
and
Yeah.
Too late.
I must have
So
All right, so all we're doing is substituting. We will substitute this -2 in anywhere that we see an x. Because it says when x equals, that means that -2 has to go in everywhere that there's an x. So the way to write this out so we know which one we're talking about is we'll remove this x and we'll put in -2 in the parentheses. So that -2 squared plus 2 times -2 plus 1. Well, that's +4. That's -4. So +4 times -4 plus 1 equals 1. Let me rewrite this out visually. We have +4 minus 4 plus 1 equals 1. Okay? Now 0. 0 squared plus 2 times 0 plus 1. 0 plus 0 plus 1 equals 1. Finally, we have a +2, which equals 2 squared plus 2 times 2 plus 1. This equals 4 plus 4 plus 1, which equals 9. So it'll be this one right here. So we are now quickly remembering that a negative 4 times negative 2 squared, or negative 2 times negative 2 is not negative 8. Because you have to remember, a negative times a negative equals a positive. What helps sometimes, and I know this is kind of weird, but on stuff like that, say it out loud or like whisper it to yourself. Because whenever you hear it audibly, it tends to trigger some of those rules. So negative 2 times negative 2. Oh, negative times a negative is a positive. Whereas if you just visually look at it, your brain may skip over some of those rules. Yes, I encourage talking to yourself in the middle of a test because it's weird. Especially when you throw in stuff like, you're better than this. Or whenever you're in the middle of a test that involves a whole bunch of strangers, then you can say, no, wait till it's lunchtime, then get them. Something like that. And then just like turn and look. Or, no, I don't need to do that to him. He looks nice. And really mess with their heads.
Guidelines for taking the next ACT.
Yes. Yes. Absolutely.
Yes.
All right. Let's see, what other do we have? Slope. Slope.
Oh, no.
Yes, slope. We'll do, okay, so find slope. That, we'll do points. Passes through 2 points. Through oh wait, I gotta check the paper. Yep. Yeah. Okay. And okay. I will let you use your books on this if you would like. Unless you already know it. But you're allowed to use your book.
We just did this. I can't remember
You have a book right in front of you.
I don't need a book.
You say that now.
Dude.
You evidently don't need a good grade either.
Ooh. You got there, Will.
Son.
Someone left numbers in here for me.
Hey, there you go. That was very nice of them.
Minus.
Too bad it wasn't a $100 bill.
I'd rather have $100 bills.
Yes.
Oh, one.
Maybe it's insightful words of wisdom that will help you
No,
achieve
very-
$100 bills.
That was a good one.
I think she did her homework.
Page 100, 101.
Yep, 100, 101.
You have it?
Hopefully.
Huh?
Hopefully.
Okay, so how did we begin working this? Let's walk through it.
Graphed it.
Huh?
Graphed it.
You graphed it. Okay, so we'll start with the graph here. We have positive 3, 1, 2, 3, and negative 4, 1, 2, 3, 4. And then positive 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and positive 2. I'm sorry. And okay.
And then you count down on the right, the y, how many down on the y, and then over to how many on the x, and then you divide y by x.
So you made a triangle out of it.
Um,
So from this point being 3 and 2, this is 7 and 2, and this is 3 and negative 4. Okay? So what's the slope? Huh?
3 over 2.
What's that?
3 over 2.
3 over 2. Is that the answer
I don't know.
that you're saying?
I don't know.
No, I'm not understanding what you were saying.
Yeah.
I just blurt out numbers sometimes too.
That's the slope.
Okay, well, I was not quite sure. So we have this graph, 3 over 2. 10 plus ball. It's a happy day. And great, I'm glad you have a happy day. So, all right, so the one method, I'm assuming that what you were saying is you're figuring out the length of a side. How'd you find the slope? Let me ask you that. So we graphed it. How did you find the slope?
Well, I actually counted down on the right side and then over. I didn't count.
So you
up-
went this
yeah.
way. Okay.
That's a completely different answer.
Went down this way
And then counted over.
and over.
And then
So
I
this is going to
divided.
be 7 and negative 4. Is this point right here. So what? Keep going.
And then I divided the 7 by the 4. Like, put 7 and then blow it 4.
Okay. So what was? So you said 7 divided by 4. And that was your answer?
Mm-hmm.
Okay.
No, I divided that. And then it got 1.75.
Okay,
That's-
why were you dividing 7 by 4?
That's the formula that they have. They have-
How did you get 7? So this is 7 here?
I had 6 for that, actually.
Okay, so the length of this side is 6. 1, 2, 3, 4, 5, 6. Okay,
And then I counted how many over from the 7.
which is what?
4.
Okay, so where did you get the 7? Like, why are you dividing 7 by 4?
I didn't originally. You said 7, and so but I originally had 6.
Okay, I was just explaining where the points are on the graph. That's all these are here.
Oh, okay, I see what you mean by there. Okay, well, I divided 6 by 4,
Okay.
and I got 1.5, and that's my answer.
Okay, so you got 6, this 6 divided by 4 will equal the slope. Okay? You're like, okay,
I was
could be?
I'm just nodding my head.
All right, so what we're looking at here, okay, if by drawing this line and looking over, we're turning this into a right triangle. This is one way of doing this. Okay? we are lucky enough that this actually falls not in between 2 points, although you could still technically do it. So from what we're looking at is making a triangle from here and over. We counted that this side is 6, this side is 4. This is a right triangle, so how do we find this, which is the slope? This part right here is the slope. How do we find out that information? What theorem do you use for a right triangle to find out the third of 3 sides? What if we named, let's say, this side A. Let's say we name this side B. And I'm just throwing a letter out there. Let's say we name this side C. So what's that again?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. So, knowing A and knowing B, we can figure out what C is.
Okay, I don't know.
So 4 squared plus 6 squared equals x squared is what we're doing on this. Or we can still use C if we want to. We'll erase that and make this C. So then 16 plus 36 equals C squared. So that is 42 equals C squared. So C equals the square root of 42.
It's 50.
Yeah. Yeah.
Very good. 52. Awesome, awesome.
I was like, I figured he'd kind of trick me on it. Double check.
So the slope would end up being square root of 52. Because that's what this is.
That's so close.
Yeah, really?
Yeah.
So close that you wouldn't provide an answer?
Yeah.
So, square root of 52 is the slope?
Doesn't that make sense?
No.
Yes, the length of this side is 52.
52. Duh.
Yeah.
Total duh moment.
I just,
So what seems to be the concern or question?
because what about the formula that has like y2 minus y1
Yeah, but we
over
did
x2
that.
minus x1?
We did that.
Okay,
It
and what does that help you find?
The second point.
It finds these the 2 sides of the other of your triangle.
Okay.
And then you can use that for that. I got to that part, but I didn't finish.
Gotcha.
So what you're talking about is we have y2 minus y1 over x2 minus x1. So we'll plug that in. 2 minus a negative 4 over 7 minus 3, which equals 6 over 4, right?
Yeah.
That's what we got.
And
Okay.
then I simplified it to 3 over 2.
3 over 2, okay. Okay, so,
And
What if you
left it.
so now what?
I don't know, I thought that was the answer, so I just used that.
Well, if you divide 3 by 2, it's 1/2, which is what I got by 6 divided by 4.
Which is what?
That's what I got by dividing 6 by 4.
Mm-hmm. So which is it then? Is it this, or is it this?
This square.
Why?
Because 6 and 4 are the sides, and we have to find the other side. Those are the wrong sides.
What is the formula for slope given 2
A
points?
squared plus B squared equals C squared. So we're not trying to divide the B side by the A side. We're trying to square those, add them all together.
Don't forget about the x.
What did we find by doing this right here? What did we find?
The hypotenuse.
That slope is really steep. No idea.
Well, think about it. this answer, explain this in layman's terms. Somebody's like, oh, well, C I see is this side, so what 52, what is it, square root of 52, what is that? What, like, explain what it is.
7.2.
No, not the answer. What is it? Like, is it the slope?
No, it's just the C.
I just really think.
Which is, keep going. The seaside, what do you mean by that?
It's just the angle of it, I think.
The angle?
No.
The length of the
Yeah, the length of it.
The length of it. Yes, very good. So from this point to this point is a square root of 52, whatever units, if we're using centimeters, meters, miles, whatever. It is simply the distance from here to here. Is that actually the slope of it? What is, and so what was the slope formula?
y2 minus y1 over x2 minus x1.
Okay,
Which
And-
equals 3 over
What?
2.
Yeah.
which 6 over 4, 3 over 2, which is what?
1 plus
What is,
5.
no, what is this in general? Whenever you have a fraction, what is that? Huh?
An improv.
No, not, think about, what is, whenever you divide one number by another number, what's another way of calling that? What's another name of talking, no, it's not Illuminati, it's not a cult-ish. So is this a rational number, irrational number? Rational. So what is the first 5 letters of rational? R-A-T-I. I got 5 of them. No, what did I just say? What were the letters again?
Ratio.
Ratio, yes. Ratio. Okay, so let's think this through. All right, a ratio means that it applies no matter what scale it is, it stays consistent, right? So, this is talking about a ratio over a period of however long that's not necessarily determined. This is a specific length that we found out. From here to here is only square root of 52. It'll change if we start stretching this out. This will no longer be, or will it be? If we start moving this out, will this change?
Yes.
It will change because this will become 5, that'll become 7. Will that stay the same? Will it still be square root of 52?
Yes.
No.
Ooh, this is a good question.
What?
Because
So let's do this.
No, it won't, because if you go, it'll be 5 and 7, and when you do 5 to the second and 7 to the second, it's going to change C.
So 49 plus 25,
seems legit.
Well, because he said.
okay, equals 60, 74. We'll C squared, so square root of 74 equals C. So that's different, right? Okay, so we physically see this. So as this stretches out, this amount, the length of the side is going to change. All right, but let's do this. If this ended up being 6 over... Now what we have to consider too is what falls on this, what actually falls on this line is, may not necessarily be 7 over 5. If we move over 1 and up 1, it may not be, this point right here on this line may not be exactly 5 and 7. Does that make sense? If we go over 1 and up 7, that may not actually land on that line. However, what does remain consistent is this right here. This ratio, this fraction, no matter where this falls on the line, whenever we go down a number of spaces and over a number of spaces, say we start from here, rationally, okay, or using the same ratio, it will still end up being reduced down to 3 over 2, or 1.5. Does that make sense? So this shows a ratio that will stay consistent no matter how much we expand this triangle or contract it. Because as long as it falls on this line, that ratio from this side to this side will still be the same. So that's where this is correct, and that's why this is correct. Does that make sense? Math, especially whenever you're going to do things correctly, it's necessary to understand why so that you know that you're doing it correctly. Just because we're given information, we start figuring stuff out. Oh yeah, this makes sense, but what did we figure out? Did we really answer the question? Or did we simply get misdirected? Does that make sense? So when going through this, understand why you are doing what you're doing. That's what makes it, one, you more confident, but then two, understanding what is really taking place. All right? Cool. Alrighty. Let's do this. X squared plus 4x plus 2 equals 0. Solve this by using the quadratic formula. Yes, you may. Solve this by using the quadratic formula. Because obviously we can't figure this out. There's no factor of 2 that when added together is going to give us a positive 4. Right? So we can't do this by factoring. We can't solve this by factoring. Okay? Like for instance, let me give you an example real quick. If you had x squared plus, we'll keep 4x, plus 3 equals 0. Well, 1 and 3, we'd have x plus 1 times x plus 3. 1 times 3 is 3, and then 1 plus 3 is 4. Well, then equals 0. To figure out the answers to this, it'd be x plus 1 equals 0, or x equals negative 1. The other one is x plus 3 equals 0. And x equals negative 3, so these are our two answers to that. And we use this, so in order to make this equation true, x would have to either equal negative 1 or negative 3. But we did this through factoring. That one's really easy. However, we may not always be able to do this through factoring, but the catch-all in any quadratic equation meaning there's an equal sign, it's going to be equal to 0, and we have an x squared, or some sort of variable squared that is not equal to 0. This cannot be 0, otherwise it's not a quadratic equation by definition.
Not the x, I thought it was the a in front of the x.
Well, yes, that's correct. If a, well, what's going to happen if a equals 0?
Wait.
Then x is going to equal, the x squared is going to equal 0. So yes, you're correct. The a in front of it, the variable in front of it cannot be 0, which would make this 0. Because 0 times anything is 0. Yeah. So our catch-all is the quadratic equation. No matter what we're given, we can use the quadratic equation and figure it out. So that's what we're doing right now. Quadratic equation, plug in your values. So in doing this, what are we doing first? We're going to identify what our A, our B, and our C is, right? not equal 1, by the way.
I was supposed to say,
I don't know why that was there. We're using the quadratic equation to solve this. The quadratic formula, I'm sorry. That's a quadratic equation. We're using the quadratic formula to solve this. Sorry. Is that bothering you?
Yeah. I think
And that's the entire problem.
Yeah, in that one instance. Okay, so somebody tell me, what is the quadratic formula?
it would be
x equals negative b plus or minus the square root of b to the second minus 4 times a times b over 2a.
Very good. Okay, so what is A? What's 1? What is B? And because each letter A, B, and C is the value of the constant that is in each of these positions. So what is B? 4. C is
2.
Okay, let's plug it in. X equals -4 plus or minus the square root of 4 squared minus 4 times 1 times 2.
It's negative 4 squared. Wait. No, it's not. No, you're good. Nope. Keep going. Forget it.
All right, I'm sorry, are you done interrupting me? I'm just
Can I
curious.
interrupt you one more time?
It's my class, not yours, just saying. Times 2 times A, which is 1. Okay, so we have -4 plus or minus the square root of 16 minus 8, which is 8, over 2. Now, what we can do is rename this as -4 plus or minus 2 to the square root of 2 over 2. And we can factor out some of this, so it would be -2 plus or minus the square root of 2. Would be the simplified answer. Okay, did anybody get anything different other than this? I ain't saying that I did.
Well, I did it wrong, so I know I got something different.
Huh?
Said I forgot to put the negative in front of the 4 when I put it, so
I
that
used my
kind of-
calculator and solved it out.
Oh, it actually gave a value? 2 values? Okay. All right, any questions with this? Y'all still scribbling this down? All right, I'm erasing it.
Wait.
Too late.
Oh, man. That's the part that you did.
It's the square root of 2.
Okay. Wait, how did
Can
you
you
use...
explain the whole thing again?
How did he use the bottom two to cross out both?
So I
Before
renamed
and
square root of 8, which
Yeah.
is 4 times 2.
Yeah,
Well, you can change that to 2 times the square root of 2.
yeah.
Well, as long as there's the same factorable, either variable or constant in all of the terms on the top and bottom, then you can factor out. There's a 2 down at the bottom, and there are 2 total terms up top. The -4 and the plus or minus 2 times the square root of 2. So there's a 2 in all of the terms, and I factored out all the 2's, and what's left is this one here, 2 plus or minus the square root of 2. This is factored out, which is over 1. You don't mark that. Does that make sense?
Yeah.
Are you sure?
I just
You're getting a lazy eye.
shouldn't there be,
No, I'm kidding.
shouldn't there be like 2 2's to take out,
Yeah.
2 2's on top?
No, because
There are. There's one in this 4, and then there's this 2 here.
Yeah, but on the bottom.
There's one down there at the bottom.
There's one.
No, there just has to be 1 in every
Oh,
term.
okay.
Whenever you take out the top, you just take out.
Yeah, so let's talk about this real quick because this commonly messes with people. Let's do this. Let's say we had 5x plus 4x squared over x. Well, there's an x that exists in all the terms. We can cross that one out, that one out, and then this one will leave 1 left over. Okay, let's do this. What about 5x plus 4x squared over 6x squared plus 1x? Well, there's an x that exists in all of the terms, okay, but there are 2 in these, so we've got to leave this here, so it would be 5 plus 4x over 6x plus 1. Okay, as long as there is something that same thing exists in all of the terms, then you can remove that amount out. Okay, it factors out. Basically, it's going to turn into a bunch of 1's. And you're multiplying times 1, and anything times 1 is itself. So you don't need it there. Okay, I'm going to move on. How about this? If we had 2x plus 2y equals 11, and x minus 2y equals 5. No. 7. Using the addition method, I want you to solve this system of functions using the addition method. Are you done?
We only have to find x, right? I remember the next one.
Yep. There's 2 letters in this one, 2 variables. That's just mean. X is the only thing that's important to me. I don't care about y. Y means you. So I don't care about you is what I'm saying. It's kind of a rude attitude. Man, it's a horrible rabbit trail to follow. God would not approve. Who has the answer so already?
Not x.
You do? What do you have?
I have x equals 6.
And?
I got that.
I didn't get that. I think you didn't want y.
Yes. See how toxic you're being?
No, no.
You're bleeding off onto other people that y doesn't matter. How dare you?
Okay, we'll figure out why.
Oh. Since I have to care about this person, fine, I will. Hey, why are people too?
Okay, I got it.
You have it?
Yes.
I just want to see how you find y. I don't know.
Why do you?
I was thinking.
What do you have?
It's 6.
Huh?
She's wrong.
So what'd you get?
I got x equals 9 and y equals 8.
Okay. X equals 9
You said use the addition method.
and y equals 8. Yep.
Alright.
I'm not good at it.
Okay.
Well, because you just add
See,
those.
Oh, it's about to turn into a brawl up in here.
I would punch someone.
I don't know anymore.
No, I should punch C first.
Wait, I can explain.
Okay. So let's explain it. Use the addition method. What do we have?
Alright, so then the 2x plus x is 3x.
3x
Equals
that.
18.
equals 18 because this is 0.
Mhm.
Right.
All right. So now how did you find x?
I divided 3 by,
18.
took 3x.
Uh-huh.
Alright, 3 divided by 18
X equals
is 9.
6.
Whoops.
It's
It's not.
equals 6. That's how I got it.
See, I
Will's wrong.
got my 9 upside down on that, or my 6 upside down.
Your 6 was upside down.
Paper
Yeah,
like
Alex.
flipped upside down. And
So x equals 6.
And y equals 0.
Oh yeah, because I
Right?
don't know why.
Right?
How did you figure y equals 0?
Well, because if you add 6, it.
Positive 2y minus 2y is 0. 0 y. It really knows
What?
No.
y.
What did we just find out in this?
Will,
I
Will
was
can't
wrong.
read.
Yes. Huh?
Well, because if you substitute 6 where all the x's are, it goes 12 over 6 plus 2y equals 11, and then 6 minus 2y equals
Why would
7.
you do the second problem though?
You can do either one. It will work for both of them.
Yeah.
So by doing this, we will find out one of the variables. Okay? The whole idea behind the addition is to be able to eliminate one of them so that you're left with one variable. And you find out the value of that one variable. And we found out that x equals 6. Okay? X equals 6. We'll leave this up over here. Now I'm going to erase all of this real quick. Okay? I'm erasing this. And now we are going to pick one of these equations and plug in 6. Okay, for x. Doesn't matter which one.
Let's do the top one.
Huh?
Let's do the top one.
Let's do the top one. Okay, so 2 times 6 equals, plus 2y equals 11. So we have 12 plus 2y equals 11. 2y equals minus 1. So y equals a minus 1/2.
That's all I got.
Okay, so y equals minus 1/2. Let's plug it into this one just to see if we came up with the same answer. To see if x, 6 being the value of x, actually does solve both of these. So 6 minus 2y equals positive 7. Minus 2y equals 1. So now we divide by a negative 2 on both sides. So y equals a minus 1/2, which is the same thing. So this will be our answer. X equals 6 and y equals negative 1/2.
That makes sense.
Okay. Now, would you be able to solve the same thing, check your answer, by doing the substitution method? You know what the substitution method is?
Yeah. You want to try it?
Well, explain what we would do.
Well, you have to get x, you choose the simpler one, so you choose x to get by itself.
Okay, this one right
And
here.
so you'd have to add 2y to the other side, and then you would take that equation and put it up where the x is, and then work that out.
Like this.
Mhm.
So then we have 4y plus 2y equals 11. So then we have 6y. Let's make sure we did this correctly. 2y plus 7. So 4y plus 14 plus 2y. So 6y equals negative 3.
Correct.
So y equals a minus 3 over 6 or a minus 1/2. So yes, we're coming up with the same answers. So be able to do that on your test. Know the addition method and know the substitution method. All right? Now, what I would also be able to do if I were you is, given a series of values, be able to find the mean, the median, and the range. Okay, you have, say, a whole herd of test scores. Be able to find the mean, median, and range. I would also be able to do this if I were you. Let's say you had a triangle. This angle is 30 degrees. This angle is, say, 75 degrees. This side is 4 and this side is 7. How would you be able to find either this angle and this side? Now this kind of catapults us into our later Algebra 2. Okay? This is not a right triangle, so what theorem will we not be using?
The a squared.
Pythagorean theorem, yes.
Well, we know the other angle.
Okay, you know the other angle, you could figure that out, but how do you figure out this side? Be able to know how to do that. Would highly suggest. Okay? Do you even remember?
I just don't remember the formula.
Okay, what do you remember?
I remember it's like an equation where like has the A, like the big A's and the little A's.
Mm-hmm. The big A is the angle measure.
Yeah.
The little a is the length of the side. Do you remember something else that you'd be using with these as far as? So, oh, I'm sorry, Teach. That was just gas. My bad.
It's not the thing in the back of the book, is it?
Huh?
Okay,
It's
no.
not the tables in the back of the book.
Not the tables in the back.
What tables are in the back of the book?
That's like
Sine?
cosine.
Would it be the log signs and cosines?
Ooh,
Yeah,
interesting.
there we go.
Now, don't get too bright, otherwise you blow the light bulb. You can only be so
Memorize
smart.
all the tables in the back of the book.
Yes. I will need you to recite that table
Alright.
by memory.
I can
Huh?
do it.
We are allowed to use calculators on this, right?
Yes, you can use calculators. I would be prepared to, you remember when you're given pieces of information and how many different ways you can combine stuff? I'd be familiar with that. Possibilities, probabilities, combinations. I'd be very prepared. It's all in the same chapter-ish.
Alright.
So I'd be prepared to know how to do those. And And you will have to graph, I will tell you this, you will have to graph an inequality. This should not be difficult for you to graph an inequality. Because what do? What's one of the things you will draw when you graph an inequality? Well, if you're going to graph, you will probably draw one of these. What's another thing you will draw? If you're given some sort of equation or inequality, what do you draw?
Just sidebar thing.
Yes, that little long cross thing. What gets labeled on there?
X and Y.
X and Y. So you will do what with this?
Put X.
You will do what with this?
We'll put different numbers in and see what works.
Numbers for what? So typically what are we doing? Putting in values for what?
Or X.
Yeah, it doesn't matter. You can
One
do
or the
either one of
other.
them. And what's one of our
And then you
favorite numbers
graph
to
it.
use?
0.
0. And then let's say this is it. You have 1 and 7 and -2 and -5, something like that. What are these?
The point thingy.
Yes, these are coordinate points that you will actually plot. Since it's an inequality, and if it's linear, then how many points must we have to confirm it?
At least 2.
Isn't it 3?
3. If it's a quadratic, so it means there's an x squared in there, how many want? 5? I want 5 points out of it to confirm what you have. Okay? Linear means there's no squared variable. All right?
Wait, you said the quadratic was 5.
Yes. So if there's an x squared or a y squared or something in there, then it's going to be quadratic, which means we want 5 to confirm it. Okay? Any questions about that?
No.
Okay. So that's pretty much it. I've given you everything you need to not study. So everything you wrote down, you can guarantee will not be on the test.
Really?
Everything else in the chapter you need to be studying.
Even the stuff you told us.
I don't like you. Like a lot. So you should, given all this information, you should be very prepared for the test. There's no reason why you should not do good on this test. Okay?
And we can
Jerome
use-
Fall.
You can use as many note cards as you want.
You can use as many note cards as you want.
Any
as
size?
many, huh?
Any size?
No.
I
Who was
think
it?
I did that last year.
Yeah, no, yes.
Yeah.
Yes.
One of those younger boys was saying like they're gonna do like that.
Yeah, and I think he kind of did.
I think
And
he
I'm not
did,
gonna, anyway. So,
I saw him somewhere doing that.
so that's it. I'm gonna